All right, I think the little schedule Sam just back channeled to me indicates that I start. So I actually, maybe we could both start. So Sam and I are both teaching not necessarily engineers. I'm actually teaching a general education class. So it's not even geology majors on water. And Sam, are you there?
I am teaching mostly environmental science and management and hydrology majors.
So we were, yeah, so we were looking for a much more general level of expertise for our module. It's called Water Planning for Sustainability, and it actually covers quite a bit. I just noticed that both of our institution logos are mountains. I don't know. Anyway, uh, all right, the first slide's mine. So the general idea of this module is to analyze both the water availability and water use in a particular area. So the first and largest component is, of course, a water budget. And we use an example from the Central Coast of California, which is very nice and contained, but of course the information is more general. So by the end of it, the idea is that students will be able to characterize a watershed in the sense that you would see in a water management plan or an environmental impact analysis. So talk about the general characteristics of it, the demographics, the hydrology, identify all the potential uses in detail. And when I say in detail, I mean in enough detail that they can propose changes at a very specific level. So for example, we get into irrigation efficiency, so that if they want to introduce later in the analysis, they want to introduce a different type of irrigation method, they can, and see how that changes the water usage. And then the ultimate goal is to create a water plan. So there are three main steps to this entire analysis. The first is working through the basics of the calculations, like what goes into water demand and supply and how you calculate it. And that's the part we have done. Or mostly done. And then looking at alternative strategies. We have a wild list, which I hope we get to complete all of those different alternatives. And then developing, the students would then propose a plan that they would incorporate, calculate the effects of and the economics of. So the learning objectives, these are our overall learning objectives, have to do with some very basic ones, understanding the components of the water cycle, like what are the important factors, and it with focus on the human components, like what are the human withdrawals, but also quite a bit on the environmental components, on environmental flows, and then getting a little more detailed in proposing their own analyses. And then communicating them, writing this up in a plan. And before we jump into the specific module outline, which Sam's going to do, I just want to point out that I think that we're setting this up in a way that it could be very modular. I know it's a module already, but you could take this first section that we've got done and just do that. In fact, that's what I intend to do. I wasn't going to really do the rest of this with my class. You could just do the develop a very detailed water budget for an area and call it a day. In addition to that, we're having the students do the analysis in spreadsheets, and I think Sam really wants his students to go through and learn how to use the spreadsheets and do the analysis. Because I'm teaching a general ed class, I'm not as convinced I can get the students to do that. So we're working on setting everything up in two different levels. So as you pick, if you chose to do this module, you'd be able to select which cohort you want to use. So one where the students go through and do the detailed analysis themselves in the spreadsheet, and one where it's some of it's done for them, and then they are looking at the results and analyzing them. All right, that was. Did I go over on the summary?
Oh,
Sam?
that's okay.
You're up.
I think no, I mean, just to reiterate, so the idea here is that the first part is really laying the foundation. And the foundation is this kind of water budget that later they are going to be playing around and changing variables. So this is the thing that we have already provided an introduction. We started actually calculating the environmental use. Typically, you start calculating population or urban. This one, we start actually putting the environment in the front and understanding what is needed to provide good habitat for the environment. So we start characterizing inflows, then estimate the domestic demand, agricultural demand, and then the water supply. Once we are here, then they will be able to analyze different strategies and basically going back to any of these and adjust some of the variables and estimate different or alternative strategies. They may even, because we provide some climate variables, they might be able also to evaluate climate change. And then we're gonna have these water quality, economics, and water demand sections. And at the end, the idea is that students individually, they will do this. And then at the end, they will come with 3 different alternatives, or students in groups of that they haven't evaluated the same alternative and discuss them.
My turn?
Yep.
Okay. Oh, and I just wanted to, there's a question in the chat about whether this would work for areas where there's no allocations. I assume you mean legislated or regulated allocations. When we say allocations, we're really talking about withdrawals. So we very specifically use data for this river system, the Pajaro River Valley in the Central Coast of California, but you could use the same techniques as long as you retrieve the data for another watershed. When we say withdrawals, we're actually just looking at the metered uses and then some estimates of other uses. That said, the first thing that we ask the students to do in the introduction is to familiarize themselves with the watershed. So we do send them to this particular watershed, which is nice because it's very discreet, it's pretty small. The Pajaro, Sam knows much more about this than I do. The Pajaro River Valley is a watershed. It's a river that drains partially from some of the coastal range mountains in California, and then so there is some snowmelt feed to it, and drains out to Monterey Bay. So it's for those of you who aren't familiar with California, it's a little south of the Bay Area. It actually drains some of the Santa Cruz Mountains also, I believe, when I looked. So the idea of this first part is we send the students to some information and ask them to characterize what the important factors are. If you're looking at a watershed, what are the things that you need to know? So we ask them to talk about climate, geography, so that what I just mentioned about the mountain ranges, what kind of precipitation they have, the hydrology of the area, so how many tributaries there are for the river, where they come from, what the water source is, any potential interaction with groundwater, which is only going to be a factor in the lower reaches of the stream, is typical of California streams. I stuck geology in there just because it's relevant in certain circumstances, and of course the demographics, because we're interested, because we're doing we're talking about water withdrawals. We're interested in where the cities are, what kind of uses there are in terms of agriculture and industry. In this particular area, there aren't many industrial uses, so that I would say that we did not include that in this analysis. However, you could, if you're doing a different river system, just by going through the same sorts of processes, including withdrawals that are taken from industry. And we put the word plagiarism up here to remind me to say that since we're sending the students to resources at this point, and then asking them to write and submit their own little summary, we thought a reminder that putting things in their own words is the entire point of this exercise. We are not interested in cutting and pasting of information from some of the documents that we've sent them to. So I don't know, like most things having to do with plagiarism, I don't know how much it helps, but we put it out there. And then the idea at the end of this entire project, they'd be producing a water plan, like a document that would be like a water plan as if they were a water management agency. So say that the Pajaro Valley Water Management Agency. So this first part, they're basically writing chapter 1 of their water plan right off the bat, which is the overview of the area. And then they move on to the first section that analyzes
environmental flows.
Which is environmental flows. And this is Sam. Go.
And basically what we're doing here is, so we introduce all the basic concepts of environmental flows, in-stream flows, natural flow regime, and then these functional flows. We have developed more than, I don't know, 5 or 6 videos where we not only explain what are the concepts, but we talked about it. And at the end, we go from this kind of conceptual model to actually how it looks for the Pájaro River. So I think that's something that we start doing there. Something that I also, at the beginning, we start kind of discussing a little bit more on that the environment is not a user, that it is the provider of water, that all water can be traced back to the environment. So I think that is the first part. This is where we start. Thanks to Jenny, I was able to put all the closed captions in the videos. So that was super cool.
All right, looks like we're up. The next section is the domestic demand, which we separate out slightly for the urban and rural areas, just so we can introduce the concept of trying to project population estimates, which is the very first thing the students are asked to do. And in quite a bit of detail, I have to say. They're asked to project it in a couple different ways, and then select what they think is the most appropriate. They calculate from metered water use, so metered water withdrawals, what the per capita water use is in the area, and then as a parallel analysis, go into a really detailed analysis of specific personal water use. So when I say detailed, it gets down to how many times do you flush the toilet per day. And the reason for this is later on when they want to propose alternative water management strategies, if they want to include conservation methods, these are the factors that they would be changing. So if we introduce a strategy where you change, you do a lawn removal program for the area, and we're changing how much water people are using for their outdoor landscaping, I need to be able to change that. So this is where that happens. So although we spend a lot of time in this beginning part setting that up, these are the pieces that they would use later on when they're proposing their changes. And then the outdoor, so the indoor demand is the typical indoor water uses. The outdoor demand gets extremely detailed. We jump right into the concepts of reference evapotranspiration and crop coefficients and irrigation efficiency and applied water, in this case, just applied to domestic landscaping. And I think we assume grass. So, however, these same concepts then immediately come back in the next module, or the next section of the module, where they're evaluating the agricultural withdrawals. So this is just an example of one of the things they're asked to produce. This is just a chart at the end of their calculations. That is the per capita water analysis, per capita water use, this is metered, of the city of Watsonville against the precipitation, the annual precipitation for that. So like, for example, one of the things that we asked them to think about and answer the question is, you can see that the water use in Watsonville has been decreasing over time. In the background section for this module, they actually saw that the water use per capita for overall for the United States has been decreasing over the same time period. Even though the population's been increasing. So here we asked them to think about, is it possible that the water use decreased because of something to do with the precipitation? And of course you can see from, we all know the answer is no, but these are the kind of questions that we're asking them to think about. And if that's not the case, why did the domestic water use decrease? So we send them to some resources at this point to look at some of the things that the Water Management Agency in Pajaro River Valley has been doing. To try to account for this change in water usage. And again, these are all done on Google Sheets is our idea, so that they'd be accessible to anyone without any special kind of software. One more thing, Sam, sorry. We also, Sam had started creating these unbelievably detailed set of instructions as he's done these exercises in his classes before. And so one of the things we've been doing is editing them to match this methodology and also using Google Sheets. So in addition to the instructions we have on the module, we have documents for each of these that are rather detailed with screenshots, so that and we've put them in a separate section of the module so that as an instructor, if they chose to use this, could either turn that on or off for their students. If they wanted to provide that level of detail, they could, or they could turn it off. Those students can't see all the screenshots. Okay. Anything else about domestic that I missed, Sam?
No, I think it's good, but something that it is that we are not kind of seeing is, so this, it will go in details. So we use data actually from the agency to estimate the different water use per capita.
Mhm.
And we go again from how many times you wash your laundry, the landscape that is outside, how many acre feet, how many square feet you have. So they will be able to change. We send it to resources to even how much, what is the ET of the different plants outside in the backyard and for trees. So this, they can modify it super in a lot of detail. Agriculture is something, is very similar. We start again with the reference evapotranspiration, crop coefficients. Then we estimate the evapotranspiration for the crops. And then we subtract the rainfall, and they estimate crop evapotranspiration and effective evapotranspiration for 9 different crops in about 24,000, 28,000 acres. So this is a super detail by month, by year. They will be able to get that. So for instance, we ask them, so compare the reference versus the crop and effective. And then here, the well-maintained grass use more water than crops. So this will be one of the graphs for the reference evapotranspiration. And this is an effective evapotranspiration of strawberries. So basically, in parts of the year, the reference, so the grass use more water than the strawberries. And that is also for to make them think like, so sometimes we kind of plant grass or we have grass, and that is using more water than some of the crops that we are growing. And then the difference between the crop evapotranspiration and effective is how much water is provided by precipitation. And then we ask them like, so how much of that water is coming from that? Yes, we have all these detail maps of land use. This is what I was talking to you. How much water is used by strawberries, vegetables, raspberries, and all the different crops, and comparing them with the precipitation, and making the point that we need water when we don't have precipitation, and how we're using aquifers and storage for doing that. This is putting the urban and the ag together. These bars here is the urban, the prediction of the annual urban and rural water demand. And this is the green bars is for agriculture. And basically we start asking them like, so these annual plots, these annual bars change. Why do they change? They change because the urban demand change or because the agricultural demand change. And that is going back to this climate, reference evapotranspiration, precipitation that is variable throughout the years. So that's how we're doing it in here. At the end, we put all of these details together into a water budget, which will be estimating first aquifer recharge, stream flow, water demands, and then doing a mass balance to estimate an aquifer storage. And so this will be in this, and also river outflow. But here, as you can see, this basin has been in overdraft for the last 50 years. So they've been actually extracting more groundwater than they are supposed to. And then we're asking them about seawater intrusion and some other problems. This will be here. At the end, they are putting this my water plan. I'm just looking at the time. Yeah.
Yeah, I was looking. It's okay. We're almost done.
Yeah. This will be at the end when they are putting together all these ideas, these different strategies here. We're providing them some conservation measures and so on. I think the key message here is that we have put together this module here. So the baseline or the water budgets, and this is my water plan. We are really looking forward to put at least these alternative strategies. We don't want the students to have this type of discussions. At the end, when all the numbers that they are doing, all the analysis that they are doing, that they are able to sit on the table and compare with each of them. I think.
And I just want to,
something that you want to add.
I just want to say when we get to the part about the alternative water strategies, we've already built into what they've done in the baseline analysis most of the work for that. So they would just be adding on to what's already been done, especially for conservation strategies. They'd basically be using the baseline analysis. Things like different alternative irrigation methods or crop pattern land use. All of that would go back and that's already in the baseline analysis that we created. So it's at least we're telling ourselves right now that the rest of this part won't take us long for us to complete. And we did have a question in the chat about attending or auditing this course. I believe that all of these courses, once they go live, anyone can look at any time. Is that correct?
Absolutely, yes. That's the whole idea.
Yeah.
I would like to audit it myself. That's really
you know something that so this first part is super time consuming, because we want to have all the details, so people, when for this part of the alternative strategies, we're just putting literary paragraphs on water conservation, thing that you're going to be changing this, and this. Hint: if you remember in this part, you use this calculation, go back and modify it. So rather than actually telling them to show them how to do it, we're just going to provide paragraphs and then hints of how they can do it. Yep. So anyway, that's where we are. This was us yesterday. We'll see. Before actually going there, any questions?
This is very nice, and like I said, I look forward to doing it myself. You know, how I mean, this is a lot of work too, you know. So how much of an effort for the student, like on average number of hours, or you think somebody will have to do?
This is 6 to 8 hours per week, I would say.
Yeah. Oh, go ahead. So Sam uses this as basically a semester-long project in his course, and I believe that if you went through and did it all the detailed analysis yourself, that's how long it would take. Since I didn't want to take as much time with it, that was one of the reasons we're developing a second way of going through it, where the student doesn't actually do the calculations, but either just looks at the results, so the resulting chart. So like, instead of going through and producing figures themselves and doing the calculations, looks at the results of them and has to answer the analysis questions. The other thing we're trying to do is I actually have a set of the spreadsheets that have JavaScript scripts in them, so that you don't have to do anything but push a button. Although I cannot, I have not yet figured out how to put that into HydroLearn. So maybe someone can help me with that, if it's possible.
So Emad, so I will say this, the characterized flows is about, this will be like 3-4 hours.
Yeah.
The domestic, it will be 6 hours. This is another 6 hours. No, this will be like 8 hours. Water supply, it will be like 4 hours.
Not as much, yeah.
Yeah. Alternative strategies will be 4 hours. And then the My Water Plan, this will be another 4 hours. Basically, for me, these are kind of weekly assignments. Each of these pieces is a weekly assignment. The other thing that I do want to everyone kind of, we have detailed instructions, like really, we have 120 pages of how to click stuff, so students will not get lost. I do that on purpose. I put it once. I know that it is painful, but you're not gonna receive emails actually saying like, Professor, how I do that? You just need to say like, really, go to the figures. It is there. It tells you what to click.
Yeah, actually, Sam, if you share the, or I can do it, the module, I can show the.
Yeah, go for it.
Okay, I just have to share the right one.
And the other thing that we were discussing at some point, perhaps recording. Yeah, go ahead, Freddie. Inviting people from the water management agency, so they actually, so they can talk with the students.
So this is the first activity, the second activity the students do where they calculate the population projections. And I just want to show, we do have instructions and they can download the spreadsheet here that we're asking them, or the template that we're asking them to use. But then these are the very detailed instructions that are embedded here. So this is, I don't even remember that we lost the pages when I turned it into an iframe.
That's
So
okay.
if that's something else we need to, we probably don't need that table of contents anymore. But this was originally a 40-page document that gets very detailed with information on how they go through and do the analysis. This is what Sam was talking about. Because this is in a separate frame, an instructor could choose to use it or not use it, so make it not available. So if you were worried about students who being able to follow this, you can see this is walking them through that very detailed. This is what you put in each cell. This is how you do the calculation. And you can also see here we're having them do 2 different regressions to determine the population projection out to the year 2050, which is what this analysis is doing. Did you have something else to add to answer that, Sam, or you?
I think that is it. It really, and many of these things, so there are many details that were not mentioned, but for instance, we are asking them to do, so for instance, a calculation on the agricultural demand using evapotranspiration and land use and so on. And then we tell them like, okay, so that is a good calculation. How sure are you that what you're doing is correct? And then we tell like, hint, here we have all the records from the Water Management Agency. Can you compare your calculations with the Water Management Agency? How do they look like? Are they close? Are they far away? In which years? Why do you think? And the same what Freddie was mentioning on the population. So you calculate it this way. Is this the only one? Have you compared it with this? So it is a lot of those. Mm-hmm.
I had a follow-up question about the amount of effort. How much time will the students spend going out and collecting data, or are they given most of the data that they need to make the calculation?
All the data is there.
I was asking because do you think it would be possible to pick a different watershed, or is it, I mean, this is really catered for that particular watershed that you guys selected?
So the equations works for everything. I think we will need to, something that we haven't thought, but perhaps we need to do is to provide a separate list of all the specific data needed for this. Also something that we didn't mention that I think is, we discussed. So most of the assignments, we have kind of an okay standard or a good enough standard. And then we have the, you wanna go for the gold, do this extra analysis or do these extra calculations and compare this and that. So we're basically throwing a lot of carrots for extra points. Mm-hmm.